Welcome to ZoomInData, your go-to channel for in-depth data engineering, analytics, and modern cloud technology interview preparation. In this video, we dive deep into the top 25 KQL and Eventhouse in Microsoft Fabric interview questions for 2025, updated as of early 2026. Perfect for data engineers, real-time analysts, architects, and anyone preparing for Fabric real-time intelligence roles. We cover Eventhouse as the scalable KQL database engine, Custo query language, KQL, syntax and capabilities, streaming integration with event streams, performance optimization, time series analysis, security, retention, scaling, Power BI integration, monitoring, and best practices, all explained in clear, interview-ready technical language to help you confidently ace your next interview. 1. What is Eventhouse in Microsoft Fabric? Eventhouse is a fully managed, scalable real-time database engine in Fabric real-time intelligence optimized for ingesting, storing, and querying high-volume streaming and event data. It provides KQL databases with automatic indexing, columnar storage, and hot, cold tiering for low-latency analytics on billions of events. Built on Custo technology, it supports continuous ingestion from event streams while exposing data via OneLake Delta format for unified access. Designed for real-time scenarios like IoT telemetry, log analytics, fraud detection, and operational monitoring with sub-second query response. 2. What is KQL? Custo query language, KQL, is a powerful, read-only query language designed for rapid analysis of large structured, semi-structured, and unstructured datasets. It features intuitive pipe-based syntax, operator, for chaining operations like filtering, projection, aggregation, joins, and time series functions. Optimized for time series and log data with built-in operators for windowing, anomalies, and machine learning extensions. Used across Eventhouse, Azure Data Explorer, Log Analytics, and Application Insights for expressive, high-performance queries. 3. How is KQL used in Fabric? KQL serves as the primary query language in Eventhouse databases for interactive exploration, materialized views, and real-time analytics. Queries execute in the real-time intelligence query editor with live previews, visualizations, and export capabilities. Integration with notebooks via %KQL magic commands enables hybrid analysis alongside PySpark or SQL code. Power BI connects via KQL queries or Direct Lake for embedding real-time insights into reports and dashboards. 4. How does Eventhouse store streaming data? Eventhouse stores data in highly compressed columnar format with automatic sharding across nodes for distributed processing. Continuous ingestion appends events to extents with hot cache for recent data and cold storage for older extents. OneLake integration exposes tables as Delta Parquet files for cross-workload access without duplication. Retention policies automatically purge data beyond configured periods while supporting time travel queries within retention. 5. How does KQL query large volumes of data? KQL leverages distributed execution across Eventhouse nodes with massive parallel processing for terabyte to petabyte scans. Operators like summarize, join, and union execute efficiently with built-in data shuffling and caching optimizations. Materialized views pre-compute and maintain aggregates incrementally for instant access to derived results. Scan limiting, Take, limit, and sampling enable rapid prototyping on massive datasets. 6. How does Eventhouse support real-time analytics? Eventhouse enables sub-second queries on freshly ingested data through optimized columnar storage and hot cache tier. Continuous ingestion from event streams lands events instantly available for KQL querying without batch delays. Materialized views continuously update aggregations as new data arrives for always current results. Data Activator monitors patterns in real time and triggers actions based on KQL-defined conditions. 7. How does Eventhouse integrate with event streams? Event streams route events directly to one or multiple Eventhouse tables with pre- or post-ingestion transformation options. Live View in event streams visualizes data flow while simultaneously populating Eventhouse for immediate querying. Schema mapping and dynamic typing handle evolving event structures during ingestion. Unified monitoring tracks end-to-end pipeline health from stream to database consumption. 8. How does KQL optimize query performance? KQL engine uses cost-based optimization, automatic caching of intermediate results, and columnar data skipping based on extent statistics. Materialized views incrementally maintain pre-aggregated results, eliminating runtime computation for common queries. Operators are highly vectorized with built-in parallelization across cluster nodes. Query insights and explain command reveal execution plans for targeted tuning. 9. How does KQL handle time series data? KQL provides dedicated time series operators like bin for bucketing, make series for gap filling, and window functions for rolling calculations. Anomaly detection functions, series_decompose_anomalies, and forecasting identify patterns automatically. Time charts and pivot by time enable intuitive visualization of trends and seasonality. Session windows and ingestion_time policy support precise event time processing. 10. How does KQL support aggregation and filtering? Summarize operator groups by dimensions with aggregations like count, sum, AVG, and dcount for distinct approximations. Where clause with efficient predicates filters early in the pipeline to minimize scanned data. Top nested, and arg_max per minute enable hierarchical and ranked aggregations efficiently. Partition operator distributes processing for very large grouped computations. 11. How does Eventhouse handle schema evolution? Dynamic typing automatically infers and adapts to new fields in incoming JSON or semi-structured events. Update policies allow explicit schema changes like promoting fields or adding calculated columns. Mapping transformations in event streams normalize schemas before ingestion. OneLake Delta compatibility supports schema evolution for downstream batch consumers. 12. How does Eventhouse manage data retention? Retention policies configure soft, hard delete periods per table or database, automatically purging old extents. Hot cache duration keeps recent data in memory, SSD, for faster access before moving to cold storage. Recoverability settings preserve deleted data temporarily for point-in-time recovery. Custom policies via KQL.set or append commands enable granular control. 13. How does Eventhouse handle security and access control? Workspace and item level RBAC controls creation, ingestion, and querying permissions. Row-level and column-level security policies in KQL restrict data visibility dynamically. Managed private endpoints secure network access to Eventhouse instances. Entra ID authentication with service principals supports automated ingestion. 14. How does KQL support joins and correlations? Join operator supports inner, left outer, right outer, full outer, and anti with multiple flavors, shuffle, broadcast. Union and lookup enable cross-table or external correlations efficiently. Time-based joins using join on ingestion_time, or nearest correlate events accurately. Materialized views pre-join common dimensions for performance. 15. How does Eventhouse support high availability? Built on geo-redundant storage with automatic failover across availability zones. Leader, follower architecture replicates metadata and extents for read scalability. Continuous ingestion remains available during cluster maintenance windows. Multi-region capacities enable cross-region disaster recovery configurations. 16. How does Eventhouse scale with data growth? Automatic sharding distributes data and queries across cluster nodes as volume increases. Capacity autoscaling dynamically adds compute resources for ingestion and query loads. Hot, cold tiering optimizes storage costs as data ages. Database sizing and throughput limits balance performance with growth. 17. How does KQL integrate with Power BI? Power BI connects via KQL database connector for live queries and visualizations. Direct Lake on Eventhouse Delta tables enables high-performance semantic models. KQL queries embed directly in reports for custom real-time metrics. Materialized views serve as optimized sources for Power BI dashboards. 18. How does Eventhouse support monitoring and diagnostics? Monitoring Hub provides real-time ingestion rates, query durations, and error metrics. Show operations and diagnostics commands reveal cluster health and extent details. Integration with Fabric capacity metrics tracks consumption and throttling. Custom KQL queries on control tables analyze historical performance. 19. How does KQL handle streaming ingestion? Ingestion_time function exposes precise timestamp for ordering and windowing on arrival time. Continuous export and materialized views process streams incrementally. Streaming policies control batching and latency for ingestion pipelines. OneLake Delta export enables downstream streaming to Lakehouse. 20. How does Eventhouse manage indexing? Automatic columnar indexing with extent level min, max statistics enables data skipping. Hot cache accelerates access to recent extents without manual intervention. Materialized views create derived indexes through pre-computation. No manual index creation required. Engine optimizes based on query patterns. 21. How does KQL handle large-scale analytics workloads? Distributed execution parallelizes across hundreds of nodes for petabyte-scale scans. Caching and materialized views eliminate repeated expensive computations. Partitioning and sharding distribute load for concurrent high-volume queries. Query prioritization and resource governance ensure SLA compliance. 22. How does Eventhouse ensure data consistency? Exactly once ingestion policies with idempotent writes prevent duplicates. Materialized views use transactional consistency for incremental updates. Snapshot isolation provides consistent reads during continuous ingestion. Delta format export maintains ACID properties for downstream consumers. 23. How does KQL support real-time dashboards? Live queries with automatic refresh deliver sub-second updates in Power BI visuals. Materialized views provide always current aggregates for dashboard metrics. Time charts and anomaly visuals render streaming patterns interactively. Data Activator triggers conditional formatting based on real-time thresholds. 24. How does Eventhouse manage cost optimization? Pay-for-use capacity charges only active ingestion and query time. Hot, cold tiering and retention policies minimize storage costs over time. Autoscaling prevents over-provisioning during variable workloads. Monitoring insights identify inefficient queries for optimization. 25. What are best practices for using KQL and Eventhouse? Use materialized views extensively for common aggregations and joins to ensure sub-second performance. Apply early filtering, projection, and time binning. Leverage ingestion_time for reliable ordering. Implement retention, hot cache policies aligned to access patterns. Monitor via control commands. Integrate with event streams for schema normalization and Power BI Direct Lake for governed real-time reporting. Thank you for watching. If this video helps you prepare for your Microsoft Fabric interview, please give it a thumbs up and share it with your network. Don't forget to subscribe to ZoomInData and hit the bell icon for more in-depth data engineering, analytics, and cloud technology interview prep videos every week. Drop your questions or topic requests in the comments. Let's zoom in on your success together.